The introduction of highly sophisticated computer modeling technologies has meant that designing the shape and form of a building is now only limited by an architect's imagination. Leading architectural practices such as Foster & Partners are designing buildings to a level of geometrical complexity unheard of 10 years ago. However, while these forms can often be achieved through off-site factory-based manufacturing techniques, there are significant limits to the levels of intricacy attainable. For example, pouring concrete into a framework can go some way to fulfilling these ambitions, but the reality is that the achievable complexity is still limited. The manufacturing processes required to turn these complex building designs into reality have remained elusive until now. This may be about to change if current research by scientists at Loughborough University comes to fruition. The research group has been inspired by 3D printing, an additive manufacturing process. Here, information created from computer-generated models is exported to a machine which then builds up a model or a component, layer by layer. The virtual model is, in effect, materialized. At Loughborough, instead of using powder and glue, they are experimenting with concrete to create large-scale building components.
The research here at Loughborough University gives us tremendous opportunities. We are able to have a little peek into the future to see what construction technology will be in the next 5 or 10 years.
Concrete printing works on the basis of a highly controlled extrusion of cement-based mortar, which is precisely positioned according to computer data. The process has the potential to create architecture that is more unique in form, but crucially, components do not have to be made from solid material, and so can use resources more efficiently than traditional techniques.
We have shown how additive manufacturing can be developed to create large structures such as panels and walls, with precisely controlled voids within them.
For example, the section which you can see being manufactured here could incorporate all the service requirements of a building, such as pipes and cables, in one unit.
This process is capable of producing building components with a degree of customization that's not yet been seen. It could create an era of architecture that's adapted to the environment and fully integrated with engineering function.
Imagine whole sections of a building being printed and then assembled on-site with their service provision already installed. Above all, imagine a building whose form and scale could take on limitless possibilities.